literally a category theory idea. It's proven inside category theory itself, but we use it a lot kind of informally. And it's kind of weird because whilst it is a category, technically and rigorously defined inside category theory proper, the idea of isomorphism is kind of ironic because it's saying roughly equivalent. What? Wait a second. That's a mathematical concept? Yes, it's a mathematical concept, roughly equivalent. Sort of like hand waving, right? Yeah. Oh, James and I are alike. Yeah. In what sense are we alike? Well, we have isomorphic ideas in relation to how, I don't know, how these seminars should be going on. So isomorphism is extremely anything. I mean, it can be applied to all kinds of situations in life. And then I would go back to the notion of simultaneity. Imagine this. So we have this concept, roughly equivalent, and it's a category. So it's rigorously defined in a mathematical theory. And yet, what we really mean when we're talking to each other is it's roughly equivalent. It's like saying, this is making fun a bit. Oh, that woman is so beautiful. Oh my God. Those Korean cheerleaders always doing the same dance. They're all so beautiful. Okay. How does that relate to isomorphism? Well, think of all the billions of viewers out there looking at this same thing. It's roughly equivalent. They're all isomorphic to that image or that video of a woman dancing. That's it. That's what we mean by isomorphic. So what kinds of things are isomorphic? Let me just give you a really down-to-earth situation why this completely abstract and strange concept of being roughly equivalent is extremely practical. I'll give you one. And if you get this one, then you'll see how powerful it can be. Let's suppose you're a farmer, a goat farmer, you have a bunch of goats on your farm and you want to take your goats to the market. Very practical, right? But you want to do it where you don't have to count anything. You don't have to use any numbers at all. Oh, wow. That's interesting. How am I going to go to the market and sell, I don't know, X number of sheep if I don't know exactly the number of sheep I have? How do I do that? Here's an incredible thing. Through isomorphisms. You use the concept of isomorphism, and you can do this extremely easily. You don't need numbers at all. That's how deeply powerful that concept of isomorphism is. You can get rid of numbers. What? And you can transact in a practical way in a market without any numbers. Right, let's do this. So how do we do it? So I'm the farmer. I've got all these sheep, and I have a bunch of rocks, and I have a sack. So for every sheep I see, I take one rock and put it in my what do you call it? In my pocket. I mean in my bag. So I see one sheep, or I'm saying one, but it could be anything. I see a sheep. I take this rock, I put it inside the sack. I see another one, I put another rock inside, and so on and so forth. By the end of quote unquote all these isomorphic relations where I have counted but not used numbers at all, I have a sack. I have a sack full of rocks. Then I go to the market. I go to the market and I talk to a trader. And to the trader, I say, okay, well, I don't know how to count, but I got these many sheep. The trader takes your sack and maybe he knows how to count, but basically now you can transact. Do you get it? And so it's an amazing concept, isomorphism. If you think about it really deeply, I mean, I've written some crazy poems about isomorphisms and love, but we're not going to go there today. That's just too much. So that's part 2 of the analysis I'm reading. of dual opposites would involve I can't see this. What does that word say? The establishment of a list of priorities of actual to potential legal relations applicable to the situation in question. So, yeah, so isomorphism just means you connect up. You like connecting the dots. So let's look at this. Let's look at this diagram. What does it say? Look. So if it says example of list of applicable legal relations by priorities of actuality to potentiality. So one, let's trace the arrow. Where does it go? It goes to 3. And immunity goes to 4. Power goes to 8. Disability goes to 7. So this complicated diagram, what's going on in this complicated diagram? What we see is that there's some kind of connection going on. What we see is that, for example, immunity, say the second one, it goes to 4. So look at the clock at the bottom. Immunity is 4. It's related to liability directly as an isomorph, as an arrow, as a morphism. And then we have disability, we have privilege, we have power, and we go all around the circle, and they're all related through these morphisms. Okay, it's a little confusing. I hope it's going to get clear in the next couple of diagrams. James, could you turn the slide? So notice how the listing of priorities of dual opposites results in a categorical theory structure. The diagram of this structure is as follows. So you have potential dual opposites and actual dual opposites, and that's one arrow. So literally, that's just going from a right to no right or something like that. And then the priorities. So which way is the best? Which way should you be going? And that's actually being listed for you in the theory. Next slide. So now we have what I call an internal diagram. The internal diagram is where the potential and actual dual opposites, as well as the priorities, are stated. Recall the illustration. So it's actually the same kind of thing. This is an example of generic internal diagram. A more detailed internal diagram would include the statement of the legal relation. X would be defined in the right or claim of X. So that's just a little bit murky, but what it means is that instead of talking about right versus no right, liability versus immunity in the abstract, or just like that, we would actually say what the right is and what the no right is, right? We'd be more specific. Okay, next slide. So you get this very interesting kind of entanglement. I make it even more abstract. So if you're getting lost, this is what kind of make you feel crazy. It looks like a spider diagram. But there you have the priorities listed in yellow. You have the actual dual opposites listed there with the morphisms, the red morphisms. And then you have the static picture of the dual opposites in the blue clocks. And this is all going on simultaneously. Huh. All right, next slide. So you might have to think about this for a couple of days to make sure you get this. I mean, when I realized what was going on, and this is actually from another book, if you don't know anything about category theory and you're not mathematical and you just think, okay, maths is impossible for me, there's actually one book that you could look at and learn this stuff. And that's by a fantastic author named Lawvere, Lawvere, and the book is titled um, conceptual mathematics, a a first introduction to categories, something like that. Actually, it's written by Lavier and Schnabel. In that book, you have this very simple diagram. And this very simple diagram really haunts me because just like everybody else, I learned the multiplication table, right? We learned how to do 2 times 3 equals 6 when we were little kids. But no one, none of my mathematical teachers ever explained to me what the hell is going on. Why does multiplication work? What's actually going on underneath the multiplication? Now, I'm just going to say it, but it's going to take a moment of nirvanic understanding on your part. No matter how much I say this, until I'm blue in the face, until you reach a realization inside you, like aha, or eureka, or wow, that's amazing, inside you, this diagram makes no difference to your life. But once you get it, it's like, huh, that's crazy. That's just so amazing. So, for example, without going into it yet, the amazing thing of multiplication as opposed to addition is that if you think of multiplication, what it is really, it's the creation of substance. All right, this is so abstract. I'm so sorry that if you don't get it and it's painful right now, I'm so sorry. And addition, all it does, it just gives you a way to separate things. So once you understand the difference between addition and multiplication, you understand the difference between things becoming a substance and things which are separated and just components. And so everything, every little thing is really just a part of another thing. And so when we create something new or something real, love, for example, it's always about a union, a joint. Here, look at this diagram closely. Again, this is analogous to the previous diagram. We're multiplying 2 times 3, and we get 6. 2 times 3, and we get 6. We have these relations. I know this is terribly abstract. We don't even have numbers on that diagram on the right. But that's what we're doing. We're creating a new substance called 6. All right, next diagram. If you want these diagrams, you can have them, you can meditate on them. Now, we go to dual correlatives. That's the second row. Remember what happens? We move from symmetry, simultaneous symmetry, which is the dual opposites, and that really gave us no information, nothing. That's just purely logical, nothing. And this is the genius of Hohfeld, really staggering genius. He moved from dual opposites to dual correlatives, and he gave us asymmetry. That is a non-symmetric way of looking at law. I can't overemphasize how great that movement is. That's like, wow. You kidding me? I mean, Joe, what are you talking about? I don't even understand your language. What the hell are you talking about? I'm saying, like, you go back to very basic principles like physics, right? Physics also does the same thing. It starts out with very symmetric assumptions about the universe. But then it says this cunning thing is that information, which is really just a surprise, requires asymmetry. So real information about anything that happens in the world to you today, now, requires asymmetry. Otherwise, you would have known it anyway. Get it? It's that close. So asymmetry is literally a surprise. Asymmetry is literally information. Asymmetry is what gives you the juice to do law. That's how deep this is. I know you maybe you have to think about this for a while because these concepts are probably all new to you. But I've been thinking about this for many years, and they're kind of not just weird, abstract. They actually work in the real world. That's what amazes me. It's not that they are just abstract concepts and they like sit on a bookshelf or PhD's thesis or something far away. No, this stuff works every day. Every time you look at a factual situation, when you come to jural correlatives, my God, it's just like amazing. All the law kind of comes to you. I wish I had learned this before I started law school. Law school would have been a lot easier, at least for me, if I had understood jural correlatives. Let me give you a little anecdote on this. Antidote. Oh, no, not antidote. Yeah. A story about Hohfeld himself. Hohfeld was taught at Yale for about 4 years, like in I don't know, teens. And it's said that Hohfeld, in his class, his kind of intro to law course, he would teach his theory, jural opposites and jural correlatives. And if the students didn't get it, like really understand it, he would hold them back. This is Yale. He wouldn't allow them to learn any other law yet. But that's crazy, right? So you're just learning four relations on their opposites and then their asymmetries. And he wouldn't let them go. Some of the students, I think, moaned and cried because he wouldn't let them go. They'd be tortured by poor Hohfeld through the spring. They start in October, and he's still teaching the same thing to the poor kids. Until they get it, he won't let them learn any other law. I think that's crazy. So it's sort of like the opposite for most of us. We learned what we thought was the law. We thought was the law. And then maybe accidentally, pure accident, we run across Hohfeld, and then we understand the law. That's very different. So in jural correlatives may be seen as the perspective of the two individuals' contrary positions to a legal relation. We say this structure conforms to the law of composition. I'm using category theory terms. Includes two entities in strict Hohfeldian terms, denoting only individuals, not other corporate legal entities such as partnerships, corporations, or trusts. I'll get into that in a second, because what that statement does, it actually implies something huge with regards to AI, super AI, general intelligence AI, super AI, whatever. That thing in the parentheses has a huge implication to what we think is AI, and a binary operation, which is a legal relation. We call the structure of structures dyadic, that's my term, distinguishing from the monadic of the jural opposites. In other words, these asymmetric jural correlatives exist together. They must exist in the legal universe, just as jural opposites exist in the logical universe. These correlatives exist in the legal universe. They must exist. Okay. That's a huge statement. It's like, what? So in effect, the idea is that, my idea what Hohfeld did, the genius of Hohfeld, is he started off logically in a kind of trivial manner, and then turned the dial. He turned it slightly. He had this beautiful clock, this mechanism, right? And then he turned the dial such that now the relations are asymmetric. It's a question in my mind when I realized what he was doing is, how did he do that? What gave him the inspiration to turn the dial slightly? That's all he's doing. So the monadic relations are perfectly logical and trivial. But when he turns the dial on them so that the relations are slightly different, wow, bursting forth from the into the universe is the legal universe. That's crazy. Get it? That's like crazy. It's like seeing a ball in the middle of your lawn, and the ball slightly changes, and the whole lawn now becomes beautiful. Why? Why did that happen? Okay, that's so mysterious to me that he should be so profound. So there you go. We redefine again these dual correlatives. We've done that in the first lecture. Let's go next slide. So using the same kind of diagram, we have a kind of rotational space similar to the dual opposites. But now the actual dual correlatives are different from the dual opposites. They're different, slightly different. Slightly different? What do I mean by slightly different? Next slide. Okay. I think the stuff in writing is extremely abstract, so I'm not going to go into it because we're talking about the algebra of law of composition and so on. I think you need to have at least a little background in maths called a group theory. So there's a cyclic symmetry in the last line of the narrative. I wish I could make this simpler. I can't. I don't know how to make this simpler. That's it. That's what it is precisely. Next slide. So just skip it. Okay, now we're gonna have some fun. I said to you just now that I don't know how Hohfeld moved the dial. How did he get the asymmetric relations such that they becomes a powerful vehicle model, literally model for the entire legal universe? How the heck did he do that? All right. So let's just look at it analytically. That is, with the eyes of a detective. So we just set it up, the two clocks. On the left is the monadic relations, the dual opposites. And on the right are the dyadic relations, the dual correlatives. So just look at it. We're examining evidence at a crime scene. That's all we're doing. Huh. Okay. That's pretty trivial. Next slide. So the question, suppose we wish to analyze the dyadic correlative right duty, right versus duty, how would we have done it given a monadic and dyadic corresponding to the dual opposites and dual correlatives? A very, very badly worded question. But basically, how do we relate the monadic diagram to the dyadic diagram? And back again, how do we relate the dyadic diagram to the monadic? That's the question, really. Next slide. Well, okay, let's do it. So on the left, monadic, we have right versus no right. On the dyadic, we have right versus duty. Yeah, the vertical. On the left, we have privilege versus duty. Okay. Where's privilege on the right? Privilege versus no right. Now, you're the detective. Suppose suppose the rest of the slides disappeared. All right. So here's the hypothetical, the thought experiment. Let's suppose this is the beginning of your analysis. What are you going to do next? This is a great question. So let's stop for a second. James, see if anybody has an answer. What would you do next, given this is the first step? What would you do next? Does anyone out there have an answer?
Lynn, Miss Lynn. Australian perspective.
They're just analyzing these two monadic and dyadic clocks with the jural opposites and jural correlatives. You begin the analysis by just looking at something, these relations, and you ask the natural question, how do they relate to each other? That's it.
The word immunity is difficult to understand it. Immunity, very special.
Oh, okay, but let's just focus on the red lines. How would the red lines relate to each other? And the red lines in the left diagram and the red lines on the right diagram.
Should I outlook? I turn like this.
Kind of. But do you notice, anyone want to say something? Let's go back to the notion of equivalence or roughly equivalent. Are there any rough equivalents between the two red lines in each of the diagrams? Are there anything that's related? Okay, let me give you a clue. Look at the top one. Look at the top. It says monadic right. It says right. And in the dyadic, we have right. Get it? They're related. Why? Because they're both right. How about the other one? Okay, how about the so there's privilege, and there's also privilege on the other side. Okay. What else? Oh, wait a second. Duty on the left, and there's also a duty on the right. Huh. Oh, wow. Fantastic. Wait a second. No right and no right, no right on the left and no right on the right. So, what can we conclude? Actually, even though they're set up differently, they're basically strongly related to each other. Get it? Because there's a right on the left and there's right on the right. There's a no right on the left. There's a no right on the right. There's a privilege on the left. There's a privilege on the right. And there's a duty on the left and the duty on the right. They're equivalent. Wow. Okay, something is very, very strange here, right? You get what I'm saying? So if you notice that actually the objects are the same, literally, but their arrangement is different. That should give you a clue. Something incredible is going on. Next slide. So what I just said is this. Okay, what I said just previously. You notice that the right and the right are related. So we draw an arrow, dotted arrow from the left to the right, dotted arrow from privilege on the left to privilege on the right, and no right to no right, from right to the left, and duty to duty, and so on. Next slide. And what you get, and I swear to you, nobody's ever seen this one before. You get a three-dimensional diagram. So in order to understand what's going on with Hohfeld, he really took it to another space, literally. He actually had conceived, well, the way I like to think about it is that the genius of Hohfeld is he didn't see things just in dyadic, linear, flat space. He saw it three-dimensionally. So do you get what's going on here in the diagram? So you have the monadic, the jural opposites on the bottom, and you have the dyadic, the jural correlatives on the top. And they're all they're related. And if you could do this like let's spend a second here. If you just trace the arrows, the red arrow to the dotted arrow and so on, if you just trace them around, an amazing thing happens, right? They're all related and it's cyclic. The structure is one structure. It's a cyclic structure. So whilst let me put it this way. Whilst the dear Professor Hohfeld gave us two tables, and if you go look at the original research, I think in 19, I always get the dates wrong, 1913 and 1917 papers, something like that. You can look up Hohfeld and in Google and get the references to his two papers. And those are the only two papers he has, by the way. They're a little complex, but even today they're worth reading. He doesn't mention any kind of three-dimensional structure in his work, right? But we know through our analysis that it must exist. That's it. This is his structure. They're related through a three-dimensional view of legal relations. All right. Again, if you want to just think about it for a while, please do. But how can I put it? This is actually what it is. It's not anything else but this. You can make all kinds of interpretations and many different examples, but it bare knuckle, like what it is abstractly, it's this. And again, I emphasize nobody else has kind of thought of Hohfeld this way. But I think if you think of Hohfeld this way, for me, I'm kind of inspired that he had such a geometric way of looking at life, right? And remember, Hohfeld, before he studied law, studied chemistry. So around that same time, one of the big inspirations in chemistry was the periodic table, was to organize everything in the universe, literally, into a few elements for which you can do recombination to make everything else in the universe. This is the same kind of thing. It's the same kind of movement of thought that Hohfeld had. Okay, next slide. The same thing. I'm just saying the same thing. Next slide. Different visualization. Okay, if you don't believe me, I turn it into composition. These lines, 1, 2, 3, 4, etc. Each one of these lines is actually written in the form of a composition. So in mathematics, we would have these arrows between objects, and that's what I'm attempting to do here. I'm not going to burden you. We'd all die before we got to even the third line. But if you trace the morphisms and create the composition, starting arbitrarily at right, privilege, power, immunity, duty, no right, liability, disability. If you start anywhere in these two diagrams and do the morphisms,